In this presentation, we're going to talk about the SRAM solver diagnostic messages. In particular, about messages CO079, no load for a load case, and GE008, no mass in the system matrix. This video is a part of a series of videos that focuses on solver diagnostic messages. If you are not familiar to this topic, we have a separate video with a proper introduction to this subject. We're going to study this model you see here, a wooden platform with steel beams. But for now, we're just going to work an example with just the beams supporting the platform. Let's see. Here is our simplified model, the steel beams. We already went over the geometry of this model on a previous exercise. I will just jump right away into the loads window. I see if I display my loads, I have a vertical point load, 200 kilonewtons, horizontal point load of 5 kilonewtons, and also a self-weight load case. So I'm interested in the results for a linear static type of analysis. So if I go to run a linear static analysis just for the load cases, and I click OK, I see I'm getting a FYI message CO079, no load for load case 3. But we already saw that I didn't assign any load for the load case number 3. I actually defined this as my self-weight load case. And just to let you know, you can also find similar messages in the new generation products like S Foundation or S Timber, which uses the same solver. To show it, here's a screenshot of the S Timber solver where I define the same model with same load cases, providing the same diagnostic message. Let's just take a look at the properties of the load. If I go to the loads window and just display my loads, I can see I have assigned the negative gravitational factor of -1 in the Z direction, so that's okay. And this may be something else happening here. What I will do next is just run a unstressed vibration or free vibration analysis. If I go to run, just select unstressed vibration and click OK. OK again. And in this case, I'm getting a different message. This is an error GE008, no mass in the system mass matrix, meaning that there's no mass added to the material of my section. So if I go back into my model, go back into the geometry window, I just want to check the material properties I have defined. If I right click, select my steel material, I can see I have a force density of 0. In order to address this, I just need to add a value for the density, update my materials, click close, and then if I run unstressed vibration analysis once again, click OK, I'm getting a clean solution. And I can see the most shapes for this structure. Now if I go to analyze and run a linear static analysis, it also comes with a clean solution. And I'm able to access the results, such as deflection for the self-weight load case, axial, shear, moments, and so on. To summarize what we learned today, the first time we ran the analysis, the solver was looking for the mass of the structure. And in order for the solver to compute this mass, it requires two things: the density of all elements, such as beams, trusses, shells, etc., and the correct dimensions. With this information, it has to calculate the volume times the density, which give us the mass. And the mass times acceleration will give us the force. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.